Welcome back to Metric Conversion and Dosages. Today we're going to talk about how a patient's weight and body surface area affect the dosage of medication that they should receive, and we're going to talk about safe dosage ranges. An order might read 25 milligrams per kilogram of some medication by mouth daily. If this order were written for a child who weighed 18 kilograms, we would start with the order 25 milligrams per kilogram, and we would multiply it by 18 kilograms, because that would allow us to cancel the kilograms, and then we would get 450 milligrams. Because I used dimensional analysis, I didn't have to think about whether I should be multiplying the 25 times 18 or dividing one by the other. Because I set it up so that the units would cancel, I knew that I needed to multiply. That said, actually when you're working with weight or you're working with BSA, all you need to do is multiply the order, whatever it is for, okay, by the weight in this case, or by the BSA, to get the answer. You don't actually need to set it up as a dimensional analysis problem. So for the sake of time, because we are interested in accuracy and speed, to save time, we're going to do it this way instead of using dimensional analysis and doing all of the setup. Children may also be prescribed medications based upon their body surface area, or BSA. And their BSA, anyone's BSA, is always reported in terms of square meters. What is a square meter? It is a square for which, am I going to be able to make a square? Kinda. Each side is equal to 1 meter. So 1 times 1 is 1, and m times n is m squared, 1 square meter. So that's another way to write square meter. This means that even if a patient's weight and height are reported in household units, you have to convert them somehow to get meters squared. Now we could convert them each individually, but instead I'm going to give you a formula that someone has already developed as a good approximation of a person's body surface area. Are we ever going to take the time to exactly calculate all of a person's body surface area? Maybe with a medical scanner, maybe some adaptation of a airport scanner would allow us to do that. But right now, we're just relying upon an approximation. It's an approximation supplied by some formulas. Okay, so BSA has two different formulas. There's a metric formula, and there's a household formula. The thing is, each of these formulas are set up so that the answer, whatever it is, comes out in meters squared, whether you start with the metric system or you start with the household system. If you've measured the patient's weight in kilograms and height in centimeters, or converted it to kilograms and centimeters, then you can multiply those two, divide by 3,600, and take the square root to get the patient's BSA. You can also calculate a patient's BSA if you have measured the patient's weight in pounds and height in inches. You multiply those two, divide by 3,131, and take the square root, and you will still get your answer in meters squared. This formula is designed so that in either case you do not need to include the units in your calculations. It will always work out to meters squared if you keep your kilograms with your centimeters and your 3,600, and you keep your pounds, inches, and 3,133 together. Keep them separate. Either use metric or use household. Do not try to mix them. If a patient is 1.53 meters tall and weighs 72 kilograms, what is her BSA? Recall that the formula for BSA requires centimeters but we have meters in the problem. Actually, that's not a problem, because we know that 1.53 meters, King Henry doesn't usually drink chocolate milk at McDonald's. Okay, we're starting at meters, which is our unit, so meters. And we're moving 1, 2 to the right to get to centimeters, so we're going to move the decimal place 2 to the right. So 153 centimeters is her height. So we have her height in centimeters, we have her weight in kilograms. We can perform this calculation. This is going to be, weight is 72, height is 153, and we are dividing by 3,600, and that gives us 1.75, and because this is the way it's calculated, meters squared is the unit. A prescription is written for 150 milligrams per meter squared of a drug by mouth every 6 hours for 5 days for this patient. How many grams total will the patient have received at the end of that period? We have an order and we have a BSA. When we multiply those two, we find that the dosage will be 262.5 milligrams for this patient. That's one dose. But this medication is being given every 6 hours. In other words, 4 doses a day for 5 days. So we could look at this as 5 days of medication at 4 doses per day. And how much is one dose? Because we need to cancel that dose. One dose is 262.5 milligrams. All right, that will allow us to cancel days, to cancel doses. We'll be left with how many milligrams this patient will have taken after 5 days. That equals 5,250 milligrams. That's milligrams. That's an awful big number. It does make sense to go to grams instead. So from milligrams to grams, we're going to go 3 to the left to give us 5.250 milligrams. A doctor prescribed 35 milligrams per meter squared by mouth immediately for a patient 5 feet 11 inches tall and 230 pounds. The safe range for this drug is 30 to 60 milligrams per day. How much medicine should you administer? The answer is none yet. Let me show you why. Let's calculate the BSA for this patient. For this patient, we can already enter the pounds, its weight, 230 pounds. We don't need the units, but we do not have the height in inches. We can convert the 5-foot portion of the patient's height to 60 inches, and then we just have to add the 11 inches. So 71 inches is the patient's height. Now, we do not take the units in to our formula, but we can complete the formula for this patient now. That will give us 2.28 square meters. All right, and then the last thing we need to do is calculate how much we will give this particular patient. The order was for 35 milligrams per meter squared. When we multiply that by 2.28 meters squared, we get 79.9 milligrams, which is way over the safe range for 1 day. In fact, this would be a good place to review another concept that we will talk about more when we get into syringes. The overdose, the amount that we're given that is an overdose, is 79.9. Whoa, we're not giving it. Do not give this. If it's not in the safe dosage, what should you do? You should go back to the prescribing doctor and question the prescription politely, respectfully, but it's your responsibility to do that. Okay, so subtract the maximum safe dosage, let's say, and we get this value, 19.9 milligrams. What percentage of overdose is that? 19.9 divided by the maximum safe dosage per day gives you 0.332, or 33.2% overdose. That's a third greater almost than what it should be. Why might that have been an error? What might the value have been? When you go back to the doctor to question this, hopefully he or she would quickly realize that perhaps they meant 25 milligrams per meter squared rather than their original number of 35. So in this case, if you multiply 25 milligrams per meter squared times the patient's BSA 2.28, you get 57.0 milligrams. Is that within the safe dosage range? Yes, it is. You may administer this revised dosage. Let's look at another example. Let's go back to a metric example. Here's an order for deltasone, prednisone, 60 milligrams per meter squared by mouth daily. How many milligrams would you administer to a patient who is 1.68 meters tall and weighs 62 kilograms? Let's first convert the 1.68 meters to centimeters. Recalling the formula for BSA using metric units, we now have 62 kilograms times 168 centimeters divided by 3,600 to give us, after we take the square root, 1.70 meters squared. Let me make some room for the next calculations we need to do. Our next step is to multiply the order, 60 milligrams per meter squared, by the BSA, 1.70 meters squared. And that gives us 102 milligrams. Let's say you have available 50 milligram tablets of the medication. How many would you give? Well, 150 milligrams times 50 milligrams per tablet would give us 2.04 tablets, which isn't going to happen. You're not going to split a tablet into 4/100ths, so you're going to administer 2 tablets. There will often be some rounding, some approximations when you're working with tablets. Although the math can be precise, you have to adapt to the real-world situation. Let me show you another example for which you will have to determine if the dosage is safe. Now, if someone does not give you the safe dosage, where would you get it? Once again, from the physician's desk reference. Here's the information about it. It's published annually. You have prescription versions, non-prescription versions, and ophthalmology versions. So you can always refer to this either in physical form or, of course, on the internet. You have an order for clarithromycin, 7.5 milligrams per kilogram orally every 12 hours. It's available under a trade name by Axin and at a dosage of 250 milligrams per 5 milliliters. That's what you have access to. The patient weighs 132 pounds. Therefore, we're going to take the order, 7.5 milligrams per kilogram, and multiply it by, we can't multiply by the weight of the patient, can we? First, we have to do a conversion. So we're going to have to convert 132 pounds to kilograms. All right, there are 2.2 pounds that are equivalent to 1 kilogram. So the patient weighs 60 kilograms. Now we can do our multiplication. 7.5 milligrams per kilogram times 60 kilograms equals, didn't leave myself much room here, 450 milligrams. And that's because those kilograms cancel, leaving us only milligrams. We have calculated the number of milligrams in one dose of clarithromycin, and specifically by Axon, through the physician's desk reference, tells us that the maximum safe dosage is 500 milligrams per dose. So we are within the safe dosage criteria. We can go ahead and administer the drug. We want to administer 450 milligrams. Whoops, too many humps there on my M. All right, and we have it available in 250 milligrams, remembering I need to flip that ratio, take the reciprocal, in order to get my milligrams to cancel, along with some common factors, and that will give me 9.0 milliliters. That concludes this video. Keep checking the physician's desk reference. Keep calculating those body surface areas for metric or for household units, and you'll do just fine. Let me know if you have any questions.